Mm. To day 5 today. So today we are going to discuss about loops, right? So last class we were discussing on conditional statements, and we saw how we could do various examples using if, else, elif, right? And we were we saw like how to do the nested if statements and how to do the multiple conditions in one code. We are able to do so. Today we are going to look at loops. So loop is another structure, another construct in Python, okay, which helps us to implement uh, scenarios where we may require a repetitive kind of code execution. So usually a program will execute in a sequential manner. So it starts from the first statement, goes to the next, then next, then next, then next, and all the way to the end. That is the sequential programming, right? Sequential execution of the code. But what we saw in branching we saw we want to execute certain code, branching or conditional statements that we saw in the previous class. So we saw if certain condition is true, then I want to execute one piece of the code. Otherwise, I want to skip it and go to the other section of the code. So that is called conditional statement or the branching, right? Today we are talking about if, let's say, this is a set of statements that I want to execute, and I want to repeat it again and again and again and again until some condition becomes true, right? So or as long as certain condition remains true, right? So that is basically Python. In Python we have loops, okay, and how to do the loops we are going to discuss those today, okay. So loops are used to execute a block of code repeatedly. As I told you, suppose this is the code of block that you want to execute, you want to keep doing it repeatedly. Okay. uh, so like there will be one execution, then another execution, then another, and then another, and this keeps on going until certain condition becomes true. Okay. So there are two primary types of loops in Python. One is the for loops and second is while loops. Okay. So for loops, these iterate means once you execute, do the one set, one execution complete, right, of the set of statements, that is known as one iteration. Okay. And when you are doing it again and again and again, we call it iterations, right? Multiple iterations of the same code we are executing, right? So for loops iterate over a sequence, exact, for example, list, tuple, or string. So if you have a sequence, okay, and you want to go over this its elements, okay, for each element in that sequence, or for certain numbers in a range, you want to repeatedly do certain things. Okay. So for loops iterate over a sequence. Okay. So just like list, tuple, string, etc. And while loops execute repeatedly as long as a condition is true. Okay. So I already told you. So I can say while, let's say I'm taking a variable n equals 1, and then I say keep executing it every time until as long as x is less than 10. And suppose every time I keep doing n equals n plus 1. Okay. So what it will do, it is going to uh, basically provide you, you know, a repetitive execution of the code n number of times, or till a condition holds true, right? So while loops execute repeatedly as long as a condition is true, We can also use a break statement in between. Break statements can be used to exit a loop prematurely. So if we want to, prematurely come out of so continue statement. So break statement, what it does, if you are executing a set of statements and somewhere you write break, then it means you want to skip from that point onwards the remaining statements in that particular set of statements. Okay. And if somewhere you write continue, continue means, okay, I have done half of this, and from here I want to go back and continue the next iteration. So suppose I'm doing something for n equals 1 to 10, let's say, then in that case what I want to do is I'm executing, let's say, up to 5, and if it is 5, I have executed certain condition is there, and I can say, okay, if this holds true, then go to the beginning of the next iteration. So that is known as the continue statement. So we have a break and a continue statement. Is this clear to you? We will go further and look at it in more detail, but I hope this is making sense, right? So give me thumbs up if everything looks okay to you guys so far. Okay, Angel. Prachi, did you understand?
Yes, sir.
Excellent. Okay, so let's move on. So how to create loops in Python? Okay, so while loop repeats a block of code as long as a condition is true, as I told you just now. So while loop, what it does, it keeps on repeating something as long as a condition is true. For example, मैंने कहा कि a variable num is there, okay, and the value of num remains less than 100 till, and means as long as the value of num remains less than 100, keep on doing it, keep on doing it, keep on doing it, right? So, and as soon as it becomes 100, okay, then you get out of it. Okay, get out of the loop. So it will skip and go to the next set of statements after the loop block. Okay. In the for loop, it iterates over a sequence. So suppose you have a list of numbers, a tuple or a string, and you say, I want to execute for each element in this list. I want to execute the code for each element in this tuple, or execute the statement for each character in a string, something like that. So then we can use the for loop over there. Okay. Then, like the way we did conditional statements, in the conditional statements we were able to nest one if else block inside the another if else block, right? So same thing we can do in case of the loops also, and we can do the nested loops. So we call them loops within loops. So suppose you are running one loop, okay, one loop from n equals 1 to 10, and then another loop you can have inside that, where suppose another variable m you can take, while m is less than or equal to 100. So suppose, so 10 into 100, so outer loop is running 1 to 10 times, let's say, and the inner loop is running 1 to 100. So total, how many iterations you are executing of the inner block? So outer one is running executing 10 times, inner one is running executing 100 times for each outer loop iteration. So total will be 10 into 100 means 1000 times that particular block, which is the inside block, that will be executed, the nested loop. We will see the examples. Okay, don't worry. Loop control statements. I just told you. So sometimes we need to control the loop. So we don't want to be executing forever, right? So we want to get out of it. So if certain condition holds true, we want to come out of the loop. Okay. Because infinite loops is something uh, we need to avoid. Okay, we have to be very, very careful when we are implementing the loops, so that we don't write something that never comes out and your program keeps on running, keeps on running, keeps on running, because it is going to consume the CPU and memory and the other resources of your system. So you don't want to write some that kind of code. Okay, your code should have a condition. It can keep on running indefinitely, no issues, as long as you have a condition to terminate it. Okay, there should be a way to come out of the loop, maybe on an instruction. You provide a instruction. For example, your operating system, once you start, it keeps on running, but when does it come out? Once you say, I want to log out, I want to shut down. Okay, so kind of your operating system application, whatever operating system you are using, Windows or Mac or Ubuntu, it keeps on running, right? It's in the memory, and then it is waiting for an operation, one action from the user. As long as user keeps giving commands, it keeps on doing certain things. But when you give it a command, okay, shut down, then it ends itself. It cleans up its memory, it cleans up all the resources, clears up all the resources, and then it ends the operating system instance and shuts down. Is that clear? Give me thumbs up if you understand that concept, or if there is in doubt, let me know. Okay, great. So so any program you write, means you are not going to write an operating system right now, because that's a very large and complex application, but you will be writing some very small programs initially. Okay, some of the problems that you face in day-to-day life, some of the problems which may be related to your uh, arithmetic exercises, your algebra or something like that, right? So you can do some different problem statements, you can pick up and you can try to solve them. Okay, then there is a range function. What is a range function? A range function generates a sequence of numbers often used for loops. So what happens if, as I told you, suppose I want to execute some code within certain range, right? Like 1 to 100 or 1 to 500 or 1 to 1000. So one way is like I create a list and there I write numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, right? But if you have to do, let's say 10,000, you are not going to write 10,000 numbers in that list, right? So you simply use the range function. So what range function does, you are telling, okay, I have this range, I want to execute this loop within this range. Okay, so we will just go next and see it. So range function generates a sequence of numbers often used for loops, right? Let's just go to the next slide and look at the loop control statements in Python. I just told you break statement. So sometimes we have to terminate the loops prematurely. So for that purpose, we use the break statement. Prematurely means if I'm executing a set of code and somewhere I say, if this condition is true, then come out. Okay, or if it is not true, then come out. So what in this helps you to control, because the loop may be running indefinitely, but that in infinite loop you want to terminate at a point when that condition becomes true, and you have to ensure that condition becomes true at one or the other time. Otherwise, again, it is an infinite loop. Even if you're writing condition, suppose you are writing a for loop to run within from 1 to 100, okay, within the range of 1 to 100, right? And for number is when the num is between 1 to 100, let's say, and you are writing a condition when n equals to 100, then break. Then it basically while loop you are having, let's say. Okay, so it is not going to ever execute that break condition, right? So the break condition should always be there. In case of the for loops, you already have a range for which you are executing, so that loop will Once the range is over, then it will automatically come out. Once the list that you are processing, that its elements end, then you will come out. But especially in the case of the while loop, okay, while loop, you put a condition. While this condition is true, keep on repeating the code. Okay, so in case of while loop, you need to have one such condition where you check if this is true, then come out. Okay, or do something within that loop so that your condition eventually becomes false at some point. So these statements are essential for controlling the flow of the loop execution, and they allow for more flexibility and efficiency in your code. Okay, proper use of break and continue can make your loops more concise and readable. So what do we call the break statement and the continuous statement? We call them control statements, loop control statements. Now, when to use loops in programming? Okay, so it's not like in every program you will require loops, but there will be majority of these scenarios where you might require loops. And what are these things? When you need to repeat a task multiple times. If you see, you want to print print hello, and let's say you want to print hello 5 times. Okay, so then you need a loop, right? Or if you want to, let's say you have to send an email. Okay, you want to send an email message to all the students in a class, and in a class there are, let's say, 50 students. So you may have a list of 50 students and their email addresses are there, and you say, I want to execute for each email address in the list, right? Then you will require a loop in such scenarios. Okay, so when something you want to do, so you want to send the email, but to whom? To each student, right? So we take one student at a time, we pick up one email address at a time and keep on repeating, okay, for each one of them until all of them are processed. So we may iterate through a sequence of elements in a list or a string or tuple, as I told you. Okay, when you need to keep performing an action until a certain condition is met. Okay, so there also you use loop. Okay, for example, as I just told you, for operating systems, so until somebody hits shutdown. Okay, maybe you want to write a program that keeps on asking an integer, like two integers, 4, 5, whatever the integer numbers a and b, two integers you are taking, and you are providing, let's say, a calculator program you wrote earlier, right? Now in that calculator program, you had written you had taken two numbers input and you are doing some calculation. If you want to keep on asking new and new combination of values, okay, till a point user enters both the numbers as 0. Okay, in that case you can write a loop over there, and you can put a condition if while this is not while a is not equal to 0 and b is not equal to 0. Okay, so that way you will be able to repeat the particular set of code and you can iterate it again and again. Okay, so sometimes we need to transform the data and perform calculations on each element in a collection, as I told you. Okay, so the collection means you may have a list of value, a collection of values. On each of the elements in that collection you want to execute certain code, so that's where also you require the loops. When you need a filter data based on specific criteria. Okay, when you to filter data based on a specific criteria, so there also you may require the loop, so you can keep going through the data. Okay, all the data element, let's say you are looking at the students in the class, who obtained more than 50% marks. Okay, so you are going through each student, and then you are finding out, if you find marks greater than 50, then print, else continue, right? So you can keep on doing, keep on doing, and that way you will be iterating through each student in the class, and eventually you will be, you know, processing all of them, and printing only those that you require as per the filter criteria. Okay, before we go any further, let's just look at some code. I will go to the coding window. I hope my window is visible to you. So I hope the coding screen window is visible to you. Give me a thumbs up if you can see it. So we will go here, and we want to write some programs. Okay, so let's do it in a file. Okay, so I'm here. So first of all, we always recommend, like, once you are writing the programs, so you do it in a folder. Okay, so you create a folder, and mkdir is a command to create a folder, and then you can do the change directory. Okay, we are already there.
Khan Academy.
Yeah, we are
Yes,
already there.
we
And
are
then
already present
ls
working at
ls is a command that we use, ls
LR,
space minus l.
LS LR. अभी कोई फाइल नहीं है.
Yeah, there is no file. Prachi, please be on mute. Okay, so ls minus ltr, ls space dash ltr, if you write, what does it mean? You want to list files. Okay, and with dash you provide the options. So this dash l means long listing. Okay, and basically you want to show in reverse order of the time, kind of. Okay, so we will just see. Currently there is no file here, so I'm going to create one file using vi is an editor, so we use vim, vi or vim editor. and we give it file. Let's say we want to uh, numbers. Okay, we want to generate a list of numbers. Okay, so I'm calling it number list dot py. Okay, now here I would like to take a number in the Vim editor. In order to modify it, insert it, you have to press I. Okay, and once you do, you will be in the insert mode. Now here I can start typing the code. Num equals, okay, so let's say I'm taking a number 1 and I say while num is less than 10, okay, or less than or equal to 10, right? I want to do print n, okay. And then after that I'm saying print, I'm done. And because this is apostrophe, so I'll put a backslash character here to make it an escape sequence. When we have to embed some special characters within the string, we put a backslash with them before them. I save this file. So now I have this file that is created on 9th of August, 7:40 p.m. 1940, and this is the file name, right? So what, in order to execute it, I will just do Python space. Before that, you can just do Python and check if Python exists. Yes, Python exists here. You can come out of it and say you can do Python space number list and enter. So we are getting an error. Why? Because let's see what is the error it is giving. In line 2, name n is not defined. We had taken a variable. Let's see what happened. So we are here. We had taken num as the variable and we are printing n. So n is not defined, right? So it should be number actually. Okay. So I do I again in order to modify number. And here, see what I'm doing is, is this code okay? Are you guys fine with this code? Means, do you think it is going to print numbers from 1 to 10? Anybody wants to comment on this? What should be the output of this code? Let's see. I'm going to execute this code number list.py. Code yaad hai aapko? What is happening? Hey, it's not stopping. It is printing 1 1 1 1 1 1 and it is not ending. Why it is not coming to I am done? Because we made a mistake. I did a control C here in order to terminate this code. Okay, we go back to the Vim editor. We find here what happened. We had assigned the value 1 to num variable. Then we said while num is less than or equal to 10, print num. Okay, very good. So it went here, it printed num. Num is the value 1, it printed. Then what happened? It again went back to over here while num is less than 10. Again it checked. Yes, num is again less than 10. It is still 1. So, and it will always remain 1 because you are not doing an increment here, right? So ideally, if we don't change the value of num, okay, then it is going to remain the same forever, right? So now I'm doing num equals num plus 1 here. So both these statements, this and this, they will execute within the loop, and because this is not at the same indentation level, so it will be executed after this block of this loop is completed actually, right? So let's see now what happens. Now let's run it again. I say Python and number list. This time we are good. It is doing, it started with 1. It is printing 1, 2, 3, 4, 5, 6, 7, 8, 9 till 10. We are given the condition while num is less than or equal to 10. Either it is less than or it is equal to 10. Now, once it printed 10 here, it went back to the while loop, and let me show you. So this was your code, right? So num equals 1. So it started from here. It kept on executing this code, right? So it came here, it checked the condition while num is less than or equal to 10. Yes, condition is satisfied. Condition satisfied. So it goes inside the loop and executes both these statements. So it prints the number, which is 1. And then it says num equals num plus 1. What does it mean? Compute the expression on the right and assign it to the variable on the left. On the right side, it becomes num was 1 and 1 plus 1 is 2. So it assigned 2 over here. Now it goes back and checks if 2 is less than or equal to 10. Answer is yes, it is less than or equal to 10. Condition is satisfied. It goes inside and it keeps on doing the same thing again and again till num remains 10. Okay. Less than or equal to 10. Num remains less than or equal to 10. Okay. As soon as once it executes for 10, then it goes here, it prints 10 and it says num equals num plus 1. Means now num value becomes 11. It goes back here. Okay, it is obeying your instructions, right? It is still goes here, checks if num is less than or equal to 10, but in this case it is not less than or equal to 10. So it says okay, goodbye. It comes here outside of this loop, so loop is over. And now in this case it prints I am done. Okay, so that's what is your outcome. So you got numbers 1 to 10 and then you say I am done. Okay, is this clear? Give me a thumbs up if you are clear. If you have any query, unmute yourself and please feel free to ask. Everyone? Angel, Prachi? Clear? Now let's do something more interesting over here. Okay. So this one we did, right? We could also do, some more things, right? So as I told you, we can do the nested loops also. We will see. Okay. Let's go back to the slide first, and then we will do some more interesting stuff with it. So few things before we move on with other examples. So there are some precautions we need to take when we are writing the loops, because loops are interesting. Do loops do the work that we need in just like a few lines of code? It can do very big tasks. Okay, however, we have to be careful when we are writing loops. One thing I told you already, we should ensure that there is an exit condition in every loop. So the loop must eventually end. Okay, it should not become an infinite loop, because if it becomes an infinite loop, your code will never end. As we did in our first case, we wrote a program, okay, and that program was never ending because we wrote the condition, okay, while num is less than or equal to 10, and we just did print num. We forgot to increment the value of none. Okay, you must do something so that it eventually leads you towards end condition. Okay, terminal condition, we call it terminal condition also. Okay, so be mindful of loop variables. Okay, don't accidentally modify them outside the loop. Okay, so some of the loop variables may be there that you are using. Maybe some of the variables you are modifying outside. Okay, and then so you might not get the expected results sometimes if at some other places your loop variable values are modified. Okay, we will see some examples in future. Okay, optimize loop efficiency. Okay, minimize unnecessary iterations and operations within the loop. You must not be doing too many iterations. Okay, if not required, right? You must be careful, you must not do too much deep nesting. Okay, because if you do nesting, okay, I'll just show you the nesting example, okay, in some time. So nesting is good, but it may be sometimes a killing one, because if you do like a loop is iterating 10 times, and inside that you are iterating 100 times, and then you are iterating 100 times again. So what it is, 100 into 100 into 10, that many times your code is executing. So be very, very careful when you're writing, especially the nested loops. Okay, consider alternative approaches. Okay, sometimes recursion or list comprehensions are more suitable. We will be seeing some examples of recursion and comprehensions in upcoming classes. For today, this is not going to be our scope of work, but we will see definitely the more advanced loop scenarios and how we can utilize the loops for creating some useful applications for our day-to-day applications. So let's see, okay, some interesting examples, some scenarios. Okay, you may note them down, and in fact this slide will be available to you, okay, after the class. So summing up numbers from 1 to 100. Now this is if you have to do the sum of numbers from 1 to 100. Okay, while there is a formula, if you are in the higher classes, you might know there is a formula to compute the sum up to 100. But if you have to do manually 1 plus 2 plus 3 plus 4 plus 5 plus 6 and up to 100, or even maybe it may be, I say I can increase the scope, I can say some numbers from 1 to 1000 or 1 to 100,000, right? So if you do it manually, that might take quite a long time. Okay, but if you do it through a loop, you may write just like a few lines of code and you can get the results within a few seconds. Okay, same way printing, let's say I give you an example of printing even numbers. Okay, between 1 and 100, so like 2, 4, 6, 8, just the even numbers or the odd numbers. Okay, that kind of problem statements you can do with the loops. Finding the factorial. How many of you are aware of factorial, term factorial? Please give me thumbs up if you know factorial. Janvi is aware. Okay, Prachi is aware. Angel is aware. Okay, Janvi, will you explain me what is factorial? If I have,
So basically,
Mhm.
yes.
Please tell me.
If there is 5 factorial, then we can expand it as 5 into 4 into 3 into 2 into 1.
Excellent, excellent. Yeah, that's right. That's very right explanation. Good. Okay, so you are aware of that. So if you have to compute the factorial of a given number, right? Let's say I say calculate the factorial of 13, right? So now you have to do the computations over there in order to uh, get this factorial number. But with the program, if you write a code once, then you just enter the number and in a fraction of a second, you will get the result. Okay. Checking if a number is prime. Okay. I enter any number and check if it is prime, right? Finding Fibonacci sequence up to a certain limit. Who all know about Fibonacci sequence? Give me a thumbs up. Janvi, very good. Angel, are you aware? Prachi, Angel. Prachi is aware. Okay, we'll just look at it. So Fibonacci sequence is something we are going to see in one of the slides shortly, but it is basically, it is the sum of two numbers. So previous, like if you do 1 1, 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, so these are the numbers in this Fibonacci sequence, and we will just see an example of that. So let's do one exercise. Okay, we want to be doing summing numbers in Python. Okay, so we want to initialize a variable called sum to 0 and use a for loop to iterate through the numbers from 1 to 100, and in each iteration add the current number to the sum variable, and after the loop completes, print the value of sum. This will efficiently calculate the sum of numbers from 1 to 100. Okay, I hope this is clear to you. So let's just look at its example. I'll share our coding screen. So let's go back. So we want to do a new file, new program we want to write. Number sum dot py. Okay, and here we want to be doing, let's say a variable is sum, or whatever the value you want to call it. So the variable is sum equals 0, and let's say now I want to do from 1 to 100, right? So let's say num equals, so what was the, we just saw the logic, right? So we can say num
Sir,
equals,
are you writing something?
I'm writing
There
on
is
the,
there is no code is showing in your screen. You already opened VM editor, but there is no editing in your edit showing, sir.
I'm sure. Do you see sum equals 0, num equals 1? No?
Wait, sir. Sir, wait, sir.
Let me know, otherwise I'll stop and start again. Let me stop it
Yes,
anyway.
sir. Sir, right now it is showing.
Okay, maybe there is bit, it is a bit slow. I'm sharing again. Visible?
Yes, sir. Yes.
Okay, great. So I'm taking sum equals 0 and I'm taking num equals 1. Now, next thing I want to do is, over here, I say while num is less than or equal to 100. Okay, I want to repeat, and I want to say sum equals sum plus num, and num equals num plus 1. That's it. I think I'm done. So what it will do, I'm saying when while the number is less than or equal to 100, initially it is 1, so I'm starting from 1. So I want to add 1 to sum, then I want to add 2 to sum, then 3 to sum, and up to 100. And I want to keep doing it as long as the value of num remains less than or equal to 100, and I'm ensuring the terminal condition is met because I'm doing num equals num plus 1. Terminal condition means when num is greater than 100. So there is one condition here: as long as it is less than or equal to 100, it keeps on increasing and keeps on iterating the loop. But when it goes above 100, then in that case it is going to terminate, okay, come out of the loop, and it will say print
It's 8 o'clock.
sum from sum of 1 to 100 is equal. And how do we print the numbers? We can maybe put braces here, and I can write sum, close it, and then I can make it an f string. Okay, and here I can make it maybe dynamically. Just leave it. We will say num to 1 to 100, this, and print I'm done. Or if you want to write, okay, it's up to you. Okay, all right, so this is my program. I escape, shift colon means column, and then W, and W for saving. If I say just W, it will just save. Shift colon W, okay, shift colon Q, quit. And if you say WQ, means save and quit, right? So now I have two files here, number list and number sum. I want to execute here Python number sum dot py. Enter. And it has given the sum from 1 to 100 is 500, 5050. Okay. Now, if I want to make it something, let's make it more interesting. I means this time it has stopped. I want to ask this number from the user, right? So what is the upper number I want to ask? So let's see. I want to say input means upper limit is equal to int input, enter an integer. Okay. All right, it goes into upper limit, and then I will say instead of 100, I say upper limit, and here instead of this 100, I print upper limit. So sum from 1 to that number, whatever we enter, equals sum. Okay, let's close it. Clear?
So you have put an extra p, I guess, while defining the value of a
Did I? Let me check. Upper limit. Yeah. Oh, there I have an extra p. You are right. Thanks for
खराब
reminding.
हो गई जैसे बात करो
Okay. Now let's execute the same. Now, let's say I'm putting 5.
मेरे तो जरा थोड़ी देर में क्लास खत्म होने वाली है
1 to 5 is sum of 1 to 5 is
मैं
50.
तो बस एक नाम के लिए बैठी हूँ और तो ये मेरा कॉन्सेप्ट क्लियर है तो इसलिए मुझे समझ में भी आ रहा है
Prachi,
मैं तो
Yeah, please be on mute. So if we say 10, then we are getting 55. If we say, let's say 1000, so it has given quickly the sum. And now if I want to be doing this, so whatever the number I'm giving, it is doing the computation, quickly giving me the results, right? And that's the advantage of scripting. While smaller computations we can do manually, but the large computations, computers are much efficient and they provide us faster results by way of doing the coding. Okay, let's do it. Means here I have to execute it every time myself. I want to make it, I want to modify it again, and let's do it, keep doing it, vim, and number sum. I want to keep doing it, right? Until I want to keep doing it, upper limit, and I want to keep doing this thing. So let's say I take initially upper limit equals, I say something, maybe 1 initially, and I say while, or it can be 0, no issues, because I'm taking it, it doesn't matter. While let's put initially some number I'm assigning here, maybe 1 greater than 0. Okay, so upper limit is not equal to 0. So I'm putting a condition, as long as upper limit is not equal to 0, or I can say upper limit is greater than 0. Okay, if I'm putting a negative number or 0, then it will terminate. Okay, and here I have to put some indentation. Okay, so what I'm doing is, while upper limit is greater than 0, every time I want to keep on asking an integer, I will execute the code within limit with this, like from num. Every time I have to initialize num also. This num I want to do 1. I will be doing this time. Instead of here, I want to do it within the loop, because for each iteration, for each each time I enter a number, num should start from 1. Num is again 1 every time. Okay, so for any number I enter, so I can enter initially, it might, I'm taking just number 1, and I'm saying as long as upper limit is greater than 1. So first time it was greater than 1, so it comes here, it is going to check while upper limit is greater than 0, condition is true. Now it goes here, asks for upper limit entry, right? Now here, okay, I enter some number. It might, if I enter something, here I can check if upper limit, if I have entered 0, for example. Okay, or I can say if upper limit is less than or equal to 0, right? In that case, I want to get out of this loop, so I am saying break. I want to do a break in that case, right? So what I'm saying, if upper limit is less than or equal to 0, when I enter the value here, okay, it checks if the upper limit is less than or equal to 0, it must break, otherwise continue. Okay, continue to num equals 1. When it breaks, so basically it goes out of current loop, whatever is this. So it goes out of this loop, it will say whatever, sum of 1 to upper limit. In this case, sum also should be reinitialized every time for the number you enter. Okay, because in the loop you are here, so we can say sum equals 0 for each number entry. Let's just see how it works. Okay, Python number sum. It says enter a number. I said 56. It keeps on asking, oh, interesting. We did something wrong. It becomes an infinite loop. Let's see. Press Control C in order to break the program. Let's see what exactly happened. So we are saying while this upper limit equals this, if upper limit is less than 0, okay, less than or equal to 0, then break. Num equals 1, while num is less than or equal to upper limit. Okay, right? So should be sum equals sum plus num. Num equals num plus 1. Okay. It has to be, the print statement is actually kept out of the loop. Print should be here at the while level. Okay. And once you get out of this loop, then I say I'm done. Okay. Let's see. So enter an integer. So I said 5. So sum of 1 to 5 is 15. Now again, it is asking integer. Okay. Again, asking the upper limit actually, right? So I said 10. This time it is giving me 55. I said 100. It gives me 5050. I say 35, 630, 13, 91, 18, 171. So some, whatever number you're giving, it keeps on going and going and going. And if I press 0, it says I am done. Okay. So because it gets out. Is this clear? Give me thumbs up if this logic is clear, or we'll go back to this code. Let's just quickly look at this code once again. Okay. And I'll share this code with you guys in the chat in case you want to use it for your practice. Okay. So I hope this is clear. So initially we did sum equals 0. Upper limit equals, we kept 1. We kept a condition over here while upper limit is greater than 0. Then we said upper limit equals int input and enter an integer. If upper limit is less than or equal to 0, then break. Break from where? Break from this loop. Okay. And if it is greater than 0, then do num equals 1, sum equals 0. And while num is less than or equal to upper limit, sum equals sum plus num equals num plus 1, and print f, whatever the f string we are writing here, and then print I'm done. Finally, once this loop is over, once you do this break, so actually you come out of this loop and you go to the next statement after this loop. So from here till here, it is one statement kind of. Okay, this entire block. Let's Did you know what will happen if I write num plus equal 1 instead of num equals num plus 1? If I write num plus equal 1, Prachi, you want to answer that? Num plus equal 1, what exactly it will do?
Uh, tell again.
Okay, hold on.
सर एक्चुअली आज मैं ना फोन में ज्वाइन की हुई है क्लास, तो आपके ना कुछ ये एनोटेशन और रिकॉर्डर वगैरह का वो ऑप्शन दिख रहा है, तो वो मुझे कंप्लीट कोडिंग नहीं दिख रही है आपकी, बाकी मेरे को समझ में आया।
ओके ओके,
आप
तो आप
थोड़ा
मोबाइल।
सा उसको, यस सर, आज मैं मोबाइल से ज्वाइन हूँ सर।
Okay, okay, no issues. I'll just show you. Okay,
यस सर, यस सर,
so I'll just go back. I hope
श्योर।
is it better now?
एक सेकेंड सर।
Angel,
यस सर, अब नाउ इट इज बेटर। आई एम seeing sir,
you
what's
able
the
to see it, right?
call
Okay.
is one.
So what
One.
I'm saying is, can you tell me if I write?
Yes.
I think we had learned the operators earlier,
Yes sir, yes sir.
and in the operators we saw this num equals num plus 1 we are doing. What happens
Yes sir.
if I write num plus equal 1? Will it be
So
the
it will work, will be same, but it is more convenient because less variable we are using. If we write num is equals to num plus one, it will take more space in our
code?
laptop or
It's more
yes.
efficient, right? So you can
Yes, it
just
is more
for
efficient. So
everyone.
we can use both codes, but it is more efficient, better than that.
Correct. So we can also make it, this also we can make it sum plus
Sum plus
equal
equals to
num.
one.
So if we write sum
Num,
plus
yes,
equal num, it is as exactly equal to sum equals sum plus num. Same way, num
yes,
plus equal 1 is equal to num equals num plus 1. Okay,
yes,
that's exactly
yes,
the same thing. So let's
yes.
just give it a try. If it is working fine, and then we will move on to the next exercise. So let's say I'm entering 56. So sum of 1 to 56 is 1596. So exactly this means we are getting the correct results here. 55, 100, 5050. And if I say 0 or minus 1, then it gives I'm done. Okay. So let's switch back to our next exercise. Next exercise is printing even numbers in Python. I will leave the code over here on the screen. You guys give it a try in your Google Colab notebooks or on your local machine. And if you can, Prachi, you don't have it, a system right now, a laptop. Let's make this code here. Okay. So what we are doing is, I'll explain you first. Okay. So we want
Yes.
to print the even numbers in. Okay. So how to do it? We are having even numbers and an empty list we are creating. Even number, list of even numbers. I'm creating an empty list over here, assigning to even numbers. And then we are iterating through this. Now, what we are doing in this case is, so let's say we are doing the sum of even numbers between 1 and 101. Okay. So means, it's a range, right? So check if the number is even. So how to check it? For the number to be even, we know the remainder, if we divide it by 2, the remainder should be 0. Those numbers which are multiples of 2 are known as even numbers. So over here we are taking the num percent 2 equal. Notice this is a double equal, not a single equal. If it is single equal means assignment. Here we are doing the comparison. So comparison operator is double equal. So we are saying if this, the remainder of num percent 2 is equal to 0, it means if it is an even number, then even numbers dot append. So what we do is, in case of the list, we have an append operation. We saw that earlier. So we can add the value of num into this even numbers list, and we keep on doing this within this range. Okay, and finally, once we are done with this range processing, then we finally print the value of even numbers. Okay, and you can notice this is indented one level back, so it is at 4th level. Okay, this 4 level. Okay, so let's quickly write this program, and then we will move on to the next screen. So let me go to the coding window. So we want to print the even numbers, right? So let's do vi even list dot py, right? So let's say even underscore numbers is equal to an empty list, and then we can say for num in range 1 to 101, and we want to say if num percent 2 is equal to 0, it means it's an even number. So I want to do even underscore numbers dot append num. Okay, and it will keep on doing this. And here I don't have to do because I'm using the for loop here instead of the while loop. So it is automatically doing the increment. Okay, it automatically goes to the next because it's doing the iteration right within this range. So it goes to 1, 2, 3, 4, 5, 6, and all the numbers in this range. And then finally I can say print even underscore numbers. Let's see what happens. I go close, and let's say Python, we had even list. So we got this even numbers list 2, 4, 6, 8, 10, 12, everything up to 100. Between 1 and 101, we got it. Okay, similarly you guys try to do it for the odd number. So if you have to do the odd, so let's make a copy of this program. CP even list with to odd list dot py. I'm making another program and I'm opening odd list. And here, if I say, if this is equal to 1, then it is an odd number. So I'll call it odd numbers. My screen is visible, Prachi? Can we?
Yes, sir. Yes, sir.
And here, if I keep on doing the odd numbers, okay, let's see how it works. So we will say Python odd numbers odd list dot py, and in this case we are getting the numbers 1, 3, 5, 7, and you may notice here it is printing. We had given the range. 1 to 101, right? But it is printing what? Only up to 99. because when we give the range, it takes one number before, right? We saw that earlier also in the previous classes. All right. So I think this is clear to you guys. Let's move on to the next slides and see few more things about the loops. I think you're not seeing this, right? Let me stop it. Let me know once the slide is visible. Sorry, I left the meeting by mistake. Let me share it. Okay, so this one we have already seen. Let's see the Fibonacci series. Okay, the Fibonacci series is, it takes an integer n as the input, representing the desired length of the Fibonacci series. In it initializes two variables a and b to 0 and 1 respectively, which represent the first two numbers in the series. The for loop iterates n times, generating the series. In each iteration, it prints the current value of A, then it updates A and B to shift the series. A becomes the previous B and B becomes the sum of previous A and B. The AND equals space string, empty string, argument in the print function ensures that the numbers are printed on the same line with a space character. So over here, as you can see, we want this kind of output: 0, 1, 2, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, the Fibonacci series numbers we want to generate. So what we did over here, we are taking one integer as an input. Then we are assigning two initial values, 0 and 1, A and B. we are assigning two values. So 0 goes to A and 1 goes to B. And then we say for I in range n, okay, it does print A, and then after that it says ends and equals this space you want to print, and A B equals B, the value of B, and the sum of the previous two numbers. The sum of means third number will be, so what we are saying, A and B. So next set of A and B will be, so when initially it is A and this is B. So when we want to compute this, so what we are saying, this plus this is equal to this. Okay. So next number will be the previous number plus and comma A plus B. So here the next, for the next iteration, we want the sum of these two numbers, means B and A plus B. So here this is A plus B. So we want B and A plus B. In this case, the sum of, if this is A and B, then 2 is A plus B. So we need B, 1 and 2 sum is 3, 3 and 2 sum is 5, 5 and 3 sum is 8, 8 and 5 sum is 13, and so on. And notice we are using these triple quotes. Triple quotes are for comments also. You can use them just like comments, because any literals, this is basically literal, but if you just write a literal, these will be ignored. Okay, this won't be executed. So let's just see how it is working. Fibonacci series. And this is an example for factorials. I will leave it for your home exercise. So let's quickly go ahead and do the Fibonacci series example. So I hope the screen is visible to you. We say Vim Fibonacci .py. All right. So let's see. So we do and because it is using this, so you can even do multi-line over here if you want. Okay. And equals int input, enter a number, and then we say we need two variables A and B, and initialize them with the value 0 and 1. You could also say A equals 0 and B equals 1 separately. It's up to you, but this is a way of writing it. For I in range what? The value n. put a column, print A, comma, okay. I want to put this, and A equals A comma B equals B comma A plus B, right? And let's see how it goes. So it keeps on printing these numbers. Let's see. It will require B also. Okay, input enter number. Oh, okay. We didn't close the parenthesis. So one parenthesis, this one is closed, but this one is not closed. So we have to fix that. So I say 5, and I'm getting 0, 1, 1, 2, 3, right? Let's say Python. I put 10. I get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Okay. So whatever the number you are giving here, that many Fibonacci numbers it is going to generate. Okay, given 100, so 100 Fibonacci numbers are this big. You can see how quickly it is computing. So just let's go back. So I hope this logic is clear to you guys. Okay. And
Why end equals to this blanks?
sorry.
Why did we put end equal to
Okay.
the string?
And equals means, okay, if I just do this, right? Then it is printing the value 0, 1, 1 this way, right? When I want to print them on one line with the space. So here I say end equals, at the end, don't take the carriage return by default. Okay. I want to print here. So in that case, it was printing A and space. So usually print statement prints one line at a time. Okay. Here by specifying and equals space or any character you want, maybe you want comma over here, comma space, right? So I'm saying the end of the line should be with this, not with the new line character. So by default, print statement is going to print a number, whatever the string you are printing, and then it goes to the next line automatically. Okay. So if I do this and I run this, print whatever the number, and then you get the comma separated list. Okay. Prachi, is that clear? Do you need any clarification on this? So by default, actually, if I don't do this, then it is going to print
Next line, in next line.
line character over there. So if you want to have something else, if you want to continue on the same line, then that's why I'm
Right, and equals
and equals space. So I want to be printing these numbers on the same line instead of the next line. So I'm just doing this. Okay.
Yes.
All right, and I'll leave this presentation. We will upload tonight. So the next exercise is the factorial computation. That logic is given to you in the slide. You can. It's not visible to you, I hope. Let me change that.
Is
So to compute the factorial, okay, the code is given to you. You guys do an experiment with this code, run it, and we will discuss it tomorrow if there is any challenge. So basically what we are doing here is we are taking a number as an input. We are checking if num is less than 0, then return error. And whatever this message, this is a continuation of this message, by the way. For it is continuation on the same line. Elif, if num is less than 0, then return, because you cannot have factorial of a negative number. If num equals 0, then return 1. That's the factorial. Okay. Else, factorial equals 1, and then initially we are taking 1, and then for I in range 1 to num plus 1, factorial into I, means this is basically factorial equals factorial into I, print finally the factorial. So this is the loop which is executing and computing the factorial, and into n minus 1 and all those things, and n from 1 to n, actually all the numbers it is taking, multiplying them with factorial every time, and then finally whatever the result is there, you are printing that factorial of so and so is factorial. It's simple code. I hope you should not have any challenge, but feel free and connect with me if you have a challenge. Okay, I'll share this with you in this slide in a short while. Okay, we'll upload it. This one you should make it return instead of print. Basically, we will say factorial equals 1. Equals 1. That's it. All right. So just do this exercise at home, and then we will review it tomorrow. Any questions you have before we end the session about today's session or previous sessions?
right now, no doubt, because I
Yeah, no,
already didn't read all the slides.
no problem. Go ahead, read them.
After 2 or 3 days, I will do all the slides or exercises, and I will, if any issue, then I will ask you.
So the next class we want to have tomorrow or day after. We have to keep one class to compensate the Wednesday one. So
Okay.
you prefer to have it this Saturday or Sunday?
Um, we can do it Saturday
We
or
can do
Sunday
Sunday
morning.
morning also. We can do Sunday morning, 11 o'clock types.
Yeah, sir, no issue.
I think Sunday morning we should do it. You will get
But you can
tomorrow's
ask,
content.
you can ask from other people if they are comfortable.
Yeah. Angel, Janvi, you guys are comfortable for Sunday?
Excuse me, sir.
Yes, Angel, tell
I
me.
think I won't be able to attend as I have to go somewhere.
Okay, how about evening, Sunday or
Sir,
tomorrow
actually,
evening?
I will be back by 6 or 7 o'clock.
When? On Sunday?
Yes. So you can do it on Saturday at the
Saturday?
same time.
Tomorrow, can we do it tomorrow morning?
No, sir.
Okay, tomorrow evening, Saturday evening, actually won't be possible, and I wanted to give you one day. Okay, so no problem. We will
So you can extend one class or
Saturday
you can shift
on the Sunday by 6 o'clock you will be back, right? So Sunday evening we can do it.
so coming Sunday.
No, this Sunday, yeah, coming Sunday, day after tomorrow.
Okay.
Okay,
Okay, sir. Please.
let's
No.
do it Sunday. We can do it same 7 o'clock, right? Sunday
Okay. Okay.
evening, 7 to 8:30. Okay.
Okay. Sir.
On it. Okay, everyone. Thank you. Bye.
Thank you, sir.